So what we're going to do is we're going to go through the chapter 3.2 questions. Okay, 3.4. And we're going to say what type of reaction it was. So if it was substance 1 and substance 2 react to produce something together, that's a formation reaction. We also have decomposition, single replacement, double replacement, and combustion. Okay, or sometimes this is corrosion, but in this case we're going with combustion. So what's the difference here? Is there's a hydrocarbon. So if it has C and H's and it's turning into carbon dioxide reacting to form carbon dioxide and water vapor, that's combustion. If you see it with oxygen and it makes an oxide with like iron oxide, for example, that would be rust, then that would give you corrosion. Okay, but chances are we're only going with combustion here. Okay, so you spent a minute doing these questions here. You had sodium and bromine, and let's see what those form. Kids, I'm making the video. You got to be quiet and stop yelling. Thank you. Okay, so what I like to do is write the whole question out by hand, not because it's fun, but because my teachers told me to, and now that I understand why, it's so that you can see what you're working on. Okay, so you're going to need your periodic table as well. So I will focus that for you. Okay, I wrote it out, and we have our chart, okay, from our textbook handy, and we also have periodic table handy with all the polyatomic ions. Okay, so what does the question say? Solid sodium. And because you have that partly memorized, okay, you know that right away it's not. Okay, if you had to spend all your time going sodium, 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 this would take you way too long. Okay, so you need to have your periodic table at least partly memorized, usually up to 20, okay, is what we tell people, but realistically we often use up to 30. Okay, those are the most common ones. So, sodium. Okay, and why does it tell us that it's solid? Because they want us to put this little S in brackets here. Okay, plus liquid bromine, so that's the only liquid at room temperature except for mercury. Okay, and why do we push this funny little L? I don't know. Okay, I think to distinguish it from a 1. Okay, so the liquid is a little cursive L. And this is not equals. Okay, like math, this is reacts to form. And then we have solid sodium, bromide. Oh, didn't even read the rest here. Sodium bromide. Sodium, which would have a 1 plus charge. Bromine, which would have a 1 minus charge. This is ionic because it has a non-metal and a metal mixed together. Okay, so our formula there would be just sodium bromide like this, 1 and 1, that balances, so we don't need any numbers down here. Okay, and it said it's solid and thermal energy. Okay, great. So we have taken element 1 plus element 2 and created an ionic compound. So what type of reaction is that? I don't know, let's look. Okay, element 1, element 2, combined, formation reaction. Okay, and textbook people are often kind of predictable. They'll often do this one first and then these ones, okay, for their questions. That's okay. So what's that called? A formation reaction. Okay, so then maybe we should actually read the question and see if we did all the things. It said to write the formula. Okay, we did that. It said to say what type it is, formation reaction, but it also said to balance the formula. Okay, so let's take a minute to do that. How many sodiums on this side? 1. How many sodiums on this side? 1. How many bromines on this side? 1. How many on this side? 1. Okay, we're done. Perfect. Okay, because we don't need to put the 1s here. We just leave it alone. Okay, so that's balanced. Hooray. Okay, and 4 minutes later, we did 1 question. Okay, chemistry takes a while, and that's okay. For this next question, let's do it together. Okay, let's have a race. Mark it go. Okay, I got my formula written. So thermal energy, lead oxide, okay, metal compound, so we care about the charges. So we have a 2+ charge. How do we know that? Because it said to use this one. Okay, because lead comes in 2 different kinds. Okay, you can either have, I know it's shaky, it's annoying. Okay, lead, you can either have the 2+ kind or the 4+ kind, right? So you need to put the 2+ kind because the question said that that's which one we use. It has this little Roman numerals 2. Okay, and oxygen is always a 2- charge. How do you know that? Because you just memorize them after a while, right? Okay, oxygen took away lead's electrons. What a bully. Okay, and then, so if we have energy and lead and it breaks down to form lead and oxygen separately, okay, then we need to look back at our chart that we totally memorized, hopefully. Okay, and when we have something breaking down, okay, that's our decomposition reaction. So we would write decomposition reaction. Okay, and then we forgot to balance. We got to balance it. This is a 3-step problem. Okay, lead, and you might be wondering, how come if you put 2 and 2, how come there's only 1 and 1? Because you only need 1 of each to balance it out. Okay, so 1, 1, 2. Oh, there's 2 here. There's only 1 here. So I need to double this. Okay, so 2 oxygens on this side, we're good. Now I have 2 leads on this side, so I need 2 leads on this side. Okay, so now we have a balanced equation. Okay, we're gonna have to do the next 2 faster because I only get a 15-minute video allowed for free. Okay, so let's do these guys. I'm gonna make it not so crooked for you. Okay, so energy and sodium nitride. So we had sodium and nitride. Okay, nitride is what, NO3 something. Oh, nitride is just IDE. Okay, it's just nitrogen. So nitride would be 3- charge. Okay. Okay, so if I had sodium and I had nitrogen, that means I need 3 sodiums to balance out my nitrogen. Okay, and I'm just going to write these so they're all on the same line. It looks pretty. Okay. So again, we would have had a decomposition reaction because we took this and broke it apart. Okay, now let's balance it. 3 sodiums, 3 sodiums. 2 nitrogens on this side. I'm going to need 2 nitrogens on this side. Okay, but now that messes up our sodium on this side. So 2 times 3 is 6. So now I need 6 of these. Okay, so 2 sodium nitrides. Oh, you forgot the solid, boy, Chuck. Okay, decomposes to make 6 sodiums and 2 nitrogen gases. Okay, and how do we know that there's a 2, right? You thought, what? How come O2, N2? There's a bunch that come in 2 packs. Okay, so hydrogen, so nitrogen, okay, chlorine, bromine, and there's a few things that come in different amounts. Sulfur is 8, might as well just try to memorize that. And there's one that comes in 4s. I think it's phosphorus. Okay, that comes in 4 packs. Okay, these 2 I wouldn't worry about for grade 10. Okay, but the halogens, okay, those come in 2 packs. Are you supposed to know that? I don't know. Your teacher will tell you. And I'm your teacher. I told you. Okay, so we're balanced. We wrote the formula. We said what kind. Okay, next one. Tin plus chlorine gas. Okay, so what's tin? Tin is SN. Should be Ti, but that's titanium. Chlorine, we just said, comes in 2 packs. Tin 4 chloride, so that's this one. I always write the charges just to make sure I don't mess it up. Okay, and that's okay to show our work. Okay, so in this one we've put 2 things together. So it's just like this top one we did earlier, formation reaction. Okay, now let's balance it. 1 tin, 1 tin. 2 chlorines, 4 chlorines. 2 times 2 is 4 chlorines, 4 chlorines. We still have the right amount of tin. We're good, we're done. Okay, that was number 2. And I'm going to pause that video so that you have time to do number 3 while it uploads to the YouTube.